thought it would be inappropriate to use slides, but I have some stuff that you really have to show to see what I'm talking about. I really have to show it to you, so I'm using slides in spite of the fact that they're not really appropriate for lightning talk. I want to talk about the Empire State Building. There it is. It's 85 stories tall up to this here point, and it was built in the 30s. And it's one of the most remarkable stories from the architecture world that I've ever run across. In August of 1929, what happened in 1929 in October?
Great Depression.
Yes, right. And in August of that year, they started thinking about building this and got a building permit. They signed a contract on September 21st, architect, owner, and builder, three-way contract. It was a fixed price contract, and they didn't have a design. They spent September, they started demolition. This was the day after the contract was signed. And they spent October and November designing the building. Well, they had the building permit for 85 stories and they had some building codes, and that was about it. They had a 20-story Waldorf Astoria hotel and a lot of other junk on a 2-square block area in the middle of New York City. On January 22nd, excavation started, and on March 17th, 1930, St. Patrick's Day, they started to dig a hole, and they started construction, and 8 months later, it looked like this, except for this top part. It was basically done in 8 months. Then the interior was finished by May 31st, 1931, and it was opened because in New York City at the time, all building contracts started on May 1st. So, all building leases. So that's why it had to be done by there. It was exactly on time, and it was 18% under budget. Now this may sound remarkable to you, except for the fact that 1 year before, these two 66-story buildings were built. This one in 12 months, that one in 18. In New York City at the time, you started a building in the spring, you finished the exterior in the fall, you finished the interior in the wintertime, and on May 1st, you rented it. That's the way it worked. They were all done like that, but then there was a crash. This was the only building built that year. The rest of them were canceled. And then there was a depression, and then there was a war. And it wasn't until the 1950s they started building buildings again. And by that time, they'd kind of forgotten how to do it. In this case, how did they do it? The biggest thing to recognize is the biggest constraint was moving all this junk onto a 2-square block in the middle of New York City in 1 year, or in 8 months. It was physically managing the flow of material, and that's all they paid attention to. They had a schedule which looked like this. They didn't have computers at the time. So maybe this was good, because all they did to schedule take a look over on this side, and I know it shows over there, but down here is January to September, and up here is sub-basement to 85th floor. This first line is when the design of the steel, this is the steel plan, was done. Notice, here is when they put the order into the mill, long before the design was done. This is when they sent the detailed design of the steel to the mill. That's the third one. The fourth column is when the steel was delivered, and the fifth column is when the steel was installed. So 1 week later. And it was pretty much like that the whole time. They thought of the work as a band marching through the building and out the top. This is interesting. It had to be 1930. And you can see, they didn't put up all the steel and then start the rest. Here's the steel, here are the windows going up, here's the stone going up, and the bottom part's done. They did something like a story a day throughout the summer. They had 4 what they called pacemakers. Stainless steel, concrete floor, exterior metal and trim, which was a separate column, not interacting in any way with any of the other pacemakers, and exterior limestone. And except for the fact that the steel had to be first, they were all separately scheduled and separately put in place. So there was no interaction between the schedules, no cascading delays. And for the steel, they had alternate steel mills every like 10 stories or so that A, B, the mills had some spare capacity and some time to catch up, and they had a backup mill just in case. So what have we learned from this? I think that we've messed ourselves up by using computers to schedule this kind of stuff. The way that they did it with flow, which actually, if you take a look, everything was done early, which meant for each separate flow, they had a pull system which said when they needed the next floor, they asked for it to come. Here are the key success factors that are widely written. I come from a family of architects, so you know. I read the architect, no I don't, but the architectural journals reported this. The teamwork of the builder, architect, and owner was the key factor. They eliminated design loops by getting anybody else involved that was necessary to make decisions. Like the elevator people, hey, they've never been an 85-story elevator before, so they had to get the elevator people, the metal people involved in detail in that October and November design phase to make sure there were no design loopbacks, and there were none. They had deeply experienced builders. Between the two brothers, one 30 and one 40 years of experience building skyscrapers. They focused on the key constraint, which was material flow. Sometimes they had many days, 500 trucks a day arriving during daylight. That's a truck a minute. Okay, no computers to schedule it, but they managed to make it happen. And the most important thing, one of the important things, is that they decoupled the pacemakers. They decoupled the schedules so that they didn't cascade and have any interlocking delays. And another interesting thing is that they had cash flow thinking, because they said $10,000 a day of capital is being tied up. So we can spend $10,000, $120,000 US dollars in today's numbers, to save any kind of time. So they spent money in order to go fast. And here's the most important thing. The schedule was not laid out based on the details of the building design. The building was designed based on the constraints of the schedule. Think about doing that for software. You think of the constraints and understand the business constraints and create a design which will fit in the constraints rather than the other way around. Here were the constraints. 2 acres of land in the middle of New York City. Zoning ordinances, which caused the step backs because of lighting ordinances. 35 million of capital. The laws of physics, you can't really violate those. And May 1st, 1931, when they had to lease the building. So what have we learned? And this is sort of my conclusion here. What we've learned is 3 things. Design to meet business constraints. Do not create schedules to meet existing designs. Go the other way around. Design to meet the business constraints of the situation. So if you have a round hole, you don't want a square peg. Secondly, workflows should be broken, separated, in order to break dependencies. It's not just architectural dependencies you want to break, it is also schedule dependencies that you should break. And thirdly, it's actually easier to control and manage workflows, like work flowing through iterations, than it is to manage schedules, especially schedules that there are a lot of detail. First you do this, second you do that, third you do that. So that's my talk, and I actually finished a minute early.
Okay. I want to go back to the industrial age, which started around 1800, but we know wasn't a single event. It was a long-standing process that went from country to country. And there were lots of factors involved. One of the factors that was important in the creation of the upheaval that made the industrial age was clocks. For the first time, individuals and organizations were able to tell what time it was. That enabled the creation of a schedule. Yay! The other interesting compounding factor was the appearance for the first time in a lot of countries simultaneously of caffeinated beverages. Now, what were people drinking before caffeinated beverages arrived? We know that if they were surviving, They were not drinking water because the water was full of nasty things. And so it's an evolutionary thing, right? Those people didn't live to produce. So the survivors, us, were produced by people who were drinking beer, exactly, exactly. About, the estimate is 3 liters per person per day. So think about it. Could we have had the industrial age, even with all the clocks in the world, if people were unable to, well, keep themselves together throughout the workday? So these 2 factors were very important in enabling us to wake up at an appropriate time, because in the past it was wake up when the sun comes up. We were really closer to the natural order of things, and to stay awake all day. So what we know is that caffeine has been around since that time, and it is probably the most popular psychoreactive drug sold. We have always assumed that it was safe. However, what we know is that the fetus and small children don't metabolize it. So that all babies born today have caffeine in their body tissues. I have a little boy in my neighborhood. He's probably 7 or 8 years old, and I asked him the other day, well, when you come home from school, what do you like to do? And he said, oh, I like to go skateboarding. But before I do, I always have 2 Red Bulls. They're little. You have to have 2. Now his mother is wondering why he doesn't sleep well. She thinks it must have something to do with the sugar in all of the soft drinks. She's not really paying attention to, because she can't. The label on the can doesn't say how much caffeine is in it. So the FDA in the United States doesn't regulate Red Bull or other energy drinks. So our children are drinking enormous quantities, even at a time when a lot of them have a long half-life for this drug. I'm not sure that this is a good idea. Every time I give this talk, I always try to find out what is the most potent drink available. It is a 20-ounce can of something called Shock. It contains 500 milligrams of caffeine in 1 can. That's approximately, depending upon how you brew it, 5 cups of coffee. And we know there might be a lot of teenagers who are drinking more than 1. There's also something new that I discovered this time. It's a soap.
A soap.
Shower Shock. Your shower in the morning can induce 200 milligrams into your bloodstream, and that's just in your morning shower before you have your cup of coffee. The thing that's happened with all of the caffeine is that now we think it would be a good thing if we didn't have to follow the sun or do a lot of other things that we've done naturally for thousands of years, one of which is sleep. We've actually gotten to the point where we denigrate sleep, naps, breaks. So I always take a poll. What's the longest period of time that you've ever sat in front of a computer working on a difficult problem and you didn't get up, not to eat, not to go to the bathroom? You sat in front of that computer screen without moving. So who can give me a time?
8 hours.
8 hours. Anyone longer than 8? 16? You didn't go to the bathroom for 16 hours?
No problem.
So you have the record. Up to this point, the longest, and I only had seen 2 individuals, have been 11 hours. So we admire those people, don't we? We think, oh, they're heroes. I wish I could be like, I don't think I could do that.
It's not heroism.
And I'm not sure, were you at your most productive?
That day?
Yes.
Yeah. That's what I kept
You
going.
believe that you were.
Well,
Of
maybe
course,
not
we
on
know
the
that you were deceiving. Research shows that caffeine is no better at improving our performance than simply taking a break or taking a nap. And caffeine does not improve learning, which is important for what we do all day. We solve complicated problems. And what the research shows is that taking a break for a certain amount of time, I'm not going to tell you what that break should be. Taking a break is better than that cup of coffee, but you didn't even take a break at all. And do you sleep much at night?
I slept really well that night.
You slept really. So let's take another poll. How many of you, let's call out, what's the longest amount of time? Anybody sleep 10 hours on an average night? 10? Sometime?
I can.
Oh, you can? Okay. That's what we used to sleep before the industrial age. Einstein always slept 10 hours at night. All right, how many? 9? Oh, this is very good. 8? Pretty good. Actually, 7 is the recommended. 7 or more. 6? 5? 4? Wow. 3? 2? 1? Good for you. All right. We know that sleep is important. We don't have a lot of time to learn about unconscious problem solving, but certainly famous problem solvers knew this secret. Thomas Edison would often take a nap in his laboratory. Of course, the gossip was that he didn't want to go home and sleep with his wife, but we won't. So while he was taking a nap, he would have ball bearings in his hand. And as he would drift off, his hand would drop. The ball bearings would fall to the floor, wake him up, and he would say, "Ah, I've got it." Have you ever had that experience?
Oh, yes.
Getting out of the shower in the morning, oh, I've got it. I've got it. Somehow handing the problem over to another part of your mind instead of the conscious awareness that was working with you for 16 hours. Somehow that enables us to be better problem solvers. A very famous French mathematician, Poincaré, said, "I have a lot of problems to solve tonight. I think I'll go to bed early." So I wonder, we know at night, we go through 90-minute cycles. Over and over again, we pass through 4 sleep phases. I wonder if we do that in the daytime. We know that there's tremendous benefit for Agile teams to develop products in small iterations. And that having a small cycle where we deliver a visible, usable increment is a good way to work. To think about working very hard for a short period of time and then taking a break. And then taking the next small step forward. I wonder if we should be thinking about, I feel like I died.
Yeah, you did.
I wonder if we should be thinking about, this is all gone now. Maybe the battery's dead. It's okay. I wonder if we should be thinking about doing that on an individual or a personal basis. I wonder if we have cycles. I wonder if we cycle in the daytime as well. And if we do, I wonder what the length of that cycle is. And I wonder how we break up those cycles, how we would say, all right, I've done a cycle, now I need to take a short break. I wonder how long that is. I read recently, again in Harvard Business Review, about an experiment that was done with managers, and they discovered a 90-minute cycle. And they felt they were more effective. And in between, they took about a 15 to 20-minute break. I think that we should look at more kinds of experiments like this. One of my favorite papers to reference was written by Arlo. Arlo, raise your hand. Yes. It's called Promiscuous Pairing. And it not only has to do with promiscuity, which might be a good thing we could think about. For those of you, I died again. For those of you who heard the talk I gave 2 years ago on bonobos and chimpanzees, I do believe there is a connection between promiscuity and agile development. We should be experimenting with that. What Arlo found is that his pairing, you were working for various intervals, and what you found was the maximum or the optimum was
90 minutes.
90 minutes. 90 minutes also. J.B. Rainsberger had an interesting paper in IEEE software just recently where he began experimenting with cycles during the day. And he divided up his workday into 90-minute cycles. I don't know, this is really interesting here. So he discovered that working for 90-minute cycles, he felt, made him more effective. And now, now there's a new book called The Pomodoro Effect. It was written by a really interesting fellow I just met in Stockholm. And he has a plan. He has a plan for experimenting to determine what your cycles are, how long your breaks should be. And it's all based around a kitchen timer that looks like a tomato, hence the name Pomodoro, which I guess translates into tomato in Italian. So I'm hoping that you'll be excited about the idea of experimenting with your own cycles, taking a break, and somehow seeing if you don't become more effective. Would you try it for me? If you'd like to have a copy of any of those papers, and I have an early PDF of the book, I'll be happy to send them to you. Thank you.
So I'm going to talk about a subject that is near and dear to my heart, which is working tiny. And as an example of this, I'm going to give 4 lightning talks in the time provided. So this is working tiny in tiny bits. So the first one is, these are all different experiences that I've had on ways that I have found to work in smaller elements. So the first thing is, how do you refactor tiny? So a little insight that I had that helped. Most languages these days are influenced by ALGOL. Most ALGOL-based languages are written left to right. That means types are defined left to right. That means that the interlocking between expressions is left to right. So when you're refactoring, if you change something on the left side of a statement, it cascades to the right. If you change something on the right side of a statement, it tends not to cascade. This means that if you're refactoring and you take each line from right to left, you can make a change, check it in, without it expanding across the whole code base, and then make the next one, and then make the next one. So if you have a statement, I have some assignment statement calling some function. In fact, probably I've got plus, c.bar. There's other stuff going on. if I take this statement from the right into the left, I can change this in a lot of different ways, and I can change this in a lot of different ways without influencing any of the stuff that happened on the line before. Which means if I want to go through my refactorings in very, very small increments, which I'll get to why shortly, then I can go through and do a single refactoring on the bar method without impacting the rest of the code. And I can chase that refactoring through, get it in, get it done. If, however, I were to change something in here, like what the type is that goes across there, that starts then, or worse yet, changing this, that starts having ramifications that filter into the return types out of these functions, that filter into the parameters passed in, and so on. So many types of expressions in many of the alcohol-derived languages are defined left to right, and that means you can refactor them right to left if you want to break them into little pieces. So that's the first talk. Told you, little insights. Okay, so the next one is a practice that Kim Walmark showed me, or helped me to learn, and I think more people should know, which is popcorn pairing. So this is a very simple approach to decreasing the, or increasing the rate of swapping between driver and navigation. Very handy because, you know, if you have that duration start getting too long, navigators fall asleep, drivers stop communicating their ideas, all sorts of problems ensue, madness. So popcorn pairing is very simple. I'm pairing with someone over here. We have a bowl of popcorn or other desirable object. Leave it to y'all. So the objective in our pair session is to individually eat as much popcorn as possible. Secondarily, code should be produced. The only rule, the rule is that once you're a driver, you have to pass the current test, commit with a commit message, and write a failing test before you're allowed to navigate again, which lets you eat popcorn. And it turns out it doesn't take very long before people start learning how to do half-line changes, how to do very small but forward progress. Okay, do it mostly as a learning exercise at first. But one of the odd things that we found is we actually were on topic more often and produced more code at the end of an hour of that than we did of typical pairing. So it also works. But, yeah. Third thing, this is another thing that I developed as a training exercise, and was shocked to discover actually worked in the real world. So sometimes you get lucky. So I was giving a talk at EuroPython several years back, and they wanted to know about this Agile thing, this XP thing, because they do a lot of Python, they did a lot of TDD, they've been doing it forever, and one of them had come to a big Agile conference, and they wanted to hear more. So I did I agreed to do a little seminar where in one day I would teach these people Agile, which fortunately they all had a shared programming language, so they could all bring a computer and we could work together. But the main thing that I did was after a very short series of tiny lectures, started iterations. And we did 90-minute iterations. And every iteration you do a planning game, then you write and deliver code, you demo it to your customer, you ship it, and then you do a retrospective. You do that in 90-minute segments. Odd thing that we discovered, and that since then, and I think even a little before then, a number of other people had independently discovered. People learn how to do a lot of the Agile practices on a per iteration basis, not on a per time basis. And people ended up being able to, the rate of success of delivering what they had planned at their iteration boundary, that always came in at the second or third iteration for 90-minute iterations or for 3-week iterations. Likewise, learning how to pair program really came in at the third or fourth iteration, whether they were 90-minute or 3-week iterations. Similarly, how to run a planning game, how to run a retrospective, a lot of these things. So, you want to learn how to do Agile? Work in really tiny segments. You can get through your first 6 iterations in 2 days. And learn what you need to learn. And so the last topic I want to talk about, the stand-up. So I'm going to talk about the stand-up mostly because I heard several different horror stories of it over the course of the day, where horror story in my mind equals serial status meeting. If you ever have a stand-up where you're going around the room and people are telling what's going on and their problems to the project manager and everyone else is waiting, that's a horrible serial status meeting. So, years back, one of my teams read Software for Your Head, and they had an interesting meeting in there that they adapted to what we called the launch meeting. The objective of a launch meeting, as opposed to a stand-up, a launch meeting is there to purely separate the time of not working from the time of working. That's its whole objective. Start and launch the team. So, as such, you can use it, we used it several times a day. You set it at the very beginning of the day, you do a launch to separate before we showed up to we're working. After lunch, you use it. Usually there's a post-lunch slump where people start, grinding a little bit and people aren't feeling so, aren't really producing very effectively. So 2 p.m., 2:30, someone notices that, calls for a launch meeting. It's separate the time of not working from the time of working and get the intensity in. So, since the whole purpose of it is to increase intensity and get to going, that means we cannot do serial status. And we cannot stand a meeting as long as 15 minutes. That is abysmally long. We couldn't tolerate it. So fortunately, the launch meeting is over in 5 minutes or less every time. And it's very invigorating. So the first thing that you do, first question you answer is, are the people good? What we mean by that is emotional check-in. Sad, mad, glad, afraid. Everybody just tell what's on your emotional radar right now. If someone broke up with their girlfriend last night, and this happened, and is perhaps feeling something about that, likely the team should be aware of this because it may impact what's going on at the job, and because you should be there for each other. Similarly, if someone is angry at the way that a piece of the code is going, or is fearful of, they've overheard some conversation that may need to lead to new requirements, then those are emotions that we want to get on the table so that we can talk about them, because they often highlight the very important things. So, people good. We want to make sure that everyone's good. If there are people who can't program, then they shouldn't program right now. Okay, next step. Is the board good? So on our team, the board, the magnetic whiteboard or chalkboard, always represents exactly the current known state of everything the team is thinking about right now. Well, in particular, the things the team is explicitly not thinking about right now, the ones they've removed from their heads and put up on the wall. So this is, does the board represent reality as the team sees it? And people good is a very quick go around. Everybody uses one of the 4 emotional words or doesn't say anything. That's okay. Board good is, does it reflect reality? The answer should almost always be yes. This should be a 2-second check. And once in a while it will be no. And if it is, if someone says no, then you swarm. Everyone in the whole team go up there and make it good all at once. So even in the case of no, you can get through this in 1 or 2 minutes and have the board reflect reality. The next is stab it. So we used push pins to indicate what each person was working on. Everyone took their flag, walked to the board, and simultaneously stabbed the card that they were going to work on. And then you adjust to make pairs. Put the least qualified people on and go. Again, very, very quick. And the last step is officially say go. The whole team says go all at once and gets off to work. Every time less than 5 minutes, and we're moving. So, thank you very much.
All right, so I am an aficionado of management. And for all of you who are technical people, you're all saying, oh God, she's one of those PHBs, pointing here at bosses. But it is my thing. It's too late in the day, not enough caffeine. That says, if we want Agile to really hit the mainstream, if we want to create environments that really allow us to work, we need to engage our managers. We need to make our managers make this happen, because we all know that middle management can kill Agile faster than anything else. You think your stand-ups are killing your team? Forget about it. It's your middle management. You think that you have a lot of work to do? Forget about it. It's your senior management or your PMO who refuse to make a decision about the project portfolio. That will kill your Agile initiative. So let me talk about what managers get paid to do. They get paid to deliver results. Now, we may not agree with all their ridiculous MBOs, that's management by objectives, because as soon as you walk down past the very top of the organization, the objectives are no longer optimized for the entire organization. Instead, they're optimized by functional group, which is ridiculous, stupid, bad, and wrong. And has, use any expletives you want. I'm wearing a microphone, I'm not allowed to. So this is, right, so management by objectives only works for CEOs because you're talking about delivering results for the entire organization. I'm not going to talk about how to change that, but managers get paid to deliver results. They also get paid to increase capacity. Now, the way they increase capacity is by initiating the hiring and initiating teams. No manager can create a team. I'm a huge fan of teams figuring out how to hire for themselves and make hiring a group thing. Those of you who are here, whenever I did my hiring thing a year or two, whatever ago, here, know what I mean about that. The other thing, the last thing, well, I don't know if I'm going in order, is that managers get paid to create an environment in which people can be successful. Right? That's all they do. They deliver results. They initiate the people stuff. They can't finish it, but they can initiate it, and they create this environment in which people can do a great job. Now, I also have this thing that the managers we have now in organizations are unaware that they are creating management debt. We know a lot about technical debt, right, thanks to Ward Cunningham, but I firmly believe that we have management debt. And the management debt is what is going to prevent us from successfully moving to Agile. We have a bunch of management debt in not managing the project portfolio and allowing multitasking. I'm going to ask you tomorrow, whoever comes to my talk, how many projects you're working on now. But the only ever acceptable answer is one. There is no need ever to work on more than one project at a time, because you can't think about more than one project at a time. You have multitasking going on, and the cost of context switching in your brain is so much higher than anyone realizes. So the only acceptable answer is one, and I cannot tell you how many managers, first-line managers, middle managers, senior managers, who are smart people and have no idea that they need to manage the project portfolio. But you can't increase capacity. You can't deliver results. And you cannot create an environment for success unless you do that stuff. Management debt occurs when managers don't make those decisions. And boy, they are hard, but they're really necessary. Now, the other thing about this business of initiating teams and creating an environment, let me just talk about feedback and coaching. Feedback and coaching are two different things. Feedback is information given in the present about an event that's hopefully in the recent past with the hopes of influencing the future, right? And especially future behavior. That's Weinberg's definition of feedback. If no one models how to give feedback in your organization, you get feedback that says, that code sucks. Well, thank you, but I don't know what to do with it. Right? Or, you're a bad person. Well, yeah, like I'm going to really hear that and respond to it in a way that makes sense. Managers can model this behavior. They can teach this behavior. They can coach this behavior. Your HR people can't. because they believe in the praise sandwich, which also sucks. That's where first you tell people they've done something good, so you build them up. Then you slap them across the face with what they think is corrective feedback, and then you build them up again. You only need to have that happen once, because as soon as you hear the beginning praise, you're turned off. That is not creating an environment in which people can do their best work. Now, if you don't give feedback, you end up with people in the wrong job. Every person in this room knows of people in the wrong job. And in the worst environments, you know of several people in the wrong jobs. Developers who cannot develop, testers who cannot test, BAs who can't analyze anything, project managers who think that project management is you do this here now, right? That's ridiculous. It doesn't matter what kind of a life cycle you use, a good project manager doesn't actually do that. So if you want to have a successful environment, you need to make sure you have the right people in the job. You can't have the right people in the job without giving them feedback. And then this business of coaching, which I think is a piece of increasing capacity. If someone asks for coaching, if someone is open to coaching, you have the ability to give them feedback. Okay, you have the ability to give them feedback and offer them coaching so they can build their capacity. So if the idea of a manager is that you deliver results, you increase your capacity, and the way you do this is by creating an environment in which people can do their best work, then what we have to do is educate our managers. We have to get rid of management debt, which first means we have to acknowledge it, and then we have to get rid of it. So get your managers to come to conferences like this. How many of these things have been about interpersonal skills, working with people, teamwork? How do you make things happen in the organization? And I'm not just talking about my lightning talk, right? This is the theme from all of today, is how do we work together? Managers can help make that happen by creating this environment for success. And they can stop it. They can cut it off at the knees if they don't do it. Thank you.